All right, everybody. Hello. Hello. So you are at the talk Making IoT, an introduction to hardware for web developers like me. My name is Kristina Durivage. I go by Galicia on Twitter. So by day, I am a senior front engineer for SmartThings, which is a home automation company owned by Samsung. And by night, but just my hobby, is building light up stuff and fun electronics projects. So I don't have an electrical engineering degree and any official training in that, but there's been advances in sort of hardware that have enabled me, novice, to kind of get into this and build really fun stuff. So I'm here to explain that and then why. So I am most known for the tweet skirt and the text sash. So the skirt came first, and what it does is there's a process that runs and pulls Twitter, and there's a curation process because of Twitter. But if you select a tweet, you can have it. People either tweet to a hashtag or a user, and after selecting a tweet as okay to show up on my clothing, you will have the tweet scroll across. And after that, I wanted it to go a little faster. And so I did the same thing with a sash and then with texting. And the idea being that someone is a little bit more respectful when it comes to what's coming out of their phone number. So far, so good. So I'm going to show you this real quick. I have the sash right here. It's like this. You wear it like that. So it says, I don't know if you can see because this light's so bright, but it says hello world right now, because of course it does. But if I go here and it doesn't work, that's great. Where's my reflector screen? Let's do this. It worked before. All right. And so then I have this here, and I go, hello, NDC, and I send that out, and I get a nice response. And what's happening kind of behind the scenes now is there's a node process that is running with Forever on DigitalOcean, and it's just looking for new messages. And eventually, it goes up through to database. And did it work? Yes. Okay, excellent. But yeah, and then so eventually it goes through, and there's a little wireless microcontroller here, which all of this I'm going to explain to you in depth later. And then you will get it to display on here. So this is like super fun and distracting, though. So we're not going to have that on the entire time because I need you to pay attention to me. So if you're not familiar with sort of the world of open hardware, it kind of got big with the Arduino Uno and the Arduino line of products. And so an Arduino Uno is like this size, so just this little rectangle here. It's not very big, and it's a little computer that you can write a C variant on and run it, and you can plug in hardware sensors or whatever, and it will run that, and you can put it in whatever. And there's the different ones here are just different iterations of the Arduino Uno, and they get as small as this, which is a tiny little Arduino. I've used this for putting on a necklace that you can wear around. So they can get from big to small. And the Arduino Mega, which is the one on the left of the Uno there, is just for really big projects where you're plugging in a bunch of sensors and LEDs and you need more pins and a little bit more processing power to do everything. And the two round ones down there are meant for textile circuits. So something like this, where this is something if you find like wires intimidating, but you know how to sew and you're kind of comfortable with that sort of handmade aesthetic, you, instead of wiring everything up, you take conductive thread, so thread made out of little metal pieces strung together, and you sew the wires up into the rest of the thing here. So this is an owl that when it gets dark, its eyes light up, which sounds really creepy, but it's kind of a fun project. So some hardware code basics, if you're not familiar with this kind of thing. Every piece of hardware code that you write for the Arduino has two functions in it. There's the setup function, which aptly named will set up all of the things that you're going to be running with in your program. And then the loop function, which just loops as fast as possible. And if you want to delay that loop, you can actually just put in a delay in it and stuff, and that's all fine. So the equivalent of the Hello World program for hardware is blinking an LED on and off. And that will look like this. A program like that looks like this, where, so I talked about how the Arduino language is a C variant. It's based on C, but then they added some kind of stuff to make it easier for Arduino programmers. And one of those things is this LED built-in variable, which will stand for a specific pin on whatever board you're using. And on the Arduino Uno, that pin is 13, D13. So you say, okay, in your setup function, here's a pin. It is this LED built-in pin. It's going to be an output, meaning you are going to output some sort of electrical current from it. And in the loop, you say write high, which is on, and then you delay a second, and then you do low, which is 0 or off, and delay a second, and then that loops, and you have a blinking LED. And so when I got started with this, when this Arduino stuff kind of came out and I started paying attention to it, it was really fun, but I had a problem. I didn't really understand the applications for it. Like, I got it for teaching, kids or people who are maybe interested in electrical engineering how to get started, but I didn't really see what it could mean for me. Like, what was I supposed to do with this? It looked kind of ugly, and it was flimsy and kind of breakable. So what's the point? Like, what's the point of this? And the point is you can put this stuff in anywhere, and you can make it as robust as you can possibly make it. But so this is a project that I did with a friend, and it got accepted into GDC, I think 2015's, like their alternative controller exhibit, where people make games that don't just use your traditional inputs. And so this is a kid's kitchen playset that I got at a garage sale for like $5. And there's a little servo on the top that spins the clock around to show how much time you have left. And the middle part there are with the different names of things are different, like the steps of the cooking process that you're supposed to participate in. And there's a pan that has these little sensors that determine what vegetable you have placed in the pan. And there's a switch for water, and then a potentiometer, which is just a knob that when you twist it to a certain point, it registers a number. And that's for, you could turn your oven on and off, basically. And this is all these servos and LEDs and touch sensors and switches and potentiometers are all found in your basic kind of Arduino Uno starter kits. And it's sort of just taking one of those kits and putting it in whatever you want and starting small with these like the small tutorials and building out and putting it in something that you can then wear somewhere. That's the application for hardware projects. So as another example here, this is simpler, but this is a Arduino Nano, which is like a little rectangle and some LEDs, and there's a battery pack or whatever. And you can make like a nice little mask like this. And this is example code like from the Arduino, like the LED stuff. There's nothing, interactive about it, but it's really cool. And I wore it to a steampunk convention and got all of the props that you can get at a steampunk convention. It was very impressive. So anyway, I was working on this stuff, and then I was thinking, they should make a thin wireless card so that I can put tweets on it. And I thought, it's probably a really bad idea. But it actually was really an excellent idea because it was super fun. And I got to be here because of it. But the project for the tweet skirt, the electronics in it aren't that more complicated than that mask. There's the microcontroller, the wireless microcontroller. So instead of just using an Arduino that doesn't talk to anything, it connects to the internet. There's a bigger battery and a different kind of voltage regulator. And then instead of like 7 LEDs, there's a bajillion of them, basically. So, but it is at the core the same thing as the mask. And the complex part was programming it. But even then, just, like anything, you can figure it out with enough Google searches. And this is what the skirt looks like. But the skirt is sort of very fragile, so I don't take it out anymore. So the core of all of these hardware projects is this company called Particle makes a bunch of different wireless controllers. They are like this size, so they're pretty small. And the difference between this and the Arduino, you write it with the same language. There's a couple little tweaks there, but it's basically the same thing. But when you plug an Arduino in, it will just run the program you flash to it. with a particle, when you plug power into it, it looks for a wireless connection. And so you set up the wireless connection at the beginning, and after that it will always connect to the wireless connections that it's seen before. But you program it over the air, like through the internet or through VS Code. They have an extension for it. So this connects up to the internet and then to the particle cloud. But if you don't want to do it with Wi-Fi, there's different options. There's the Electron, which is cellular. It takes a SIM card and it connects up to the cellular network. And there's also some other boards that do the mesh programming, which is more for if you have a lot of sensors over a large area and you want the microcontrollers to talk to each other. So this is about $20, or that in Norwegian money. And so it's $20 is a little expensive for these boards. Like the Arduino Uno, you can usually get for like less than half that. But what this gets you is the particle cloud, is access to the particle cloud. So like I know how to do web development, and I know how to do one side of it. And I can figure out C enough to do what I want to do, or I'll just, hunker down and get through it. I do not want to handle the communication between the two of them, or that platform that makes sure that messages get sent to the right thing. It's boring and complicated, and it's not really what I'm interested in. So being able to connect to the particle cloud can just take care of that for you. There's also other alternatives to wireless cards, like the ESP8266 is more of the open one, but then you do have to do more of it yourself. So, and then the other part of this project are the LEDs. So LEDs just emit light, and there's different ones. The ones that I really like are the NeoPixels. So NeoPixels are, so Adafruit, which is like a popular website for selling this stuff, likes to give kind of like nice, friendly names to some of these electronic components, because WS2812 is not really what you would want to tell a bunch of kids this is. But they are the same thing. And you can get them in, so the sash has like that array of them, and then I'm going to be showing you soldering a sequin of them, and they also come as like Christmas lights form, which is like this. So they're like pre-wired Christmas lights form, or this like, just single things, like in kind of any sort of form that you would want to have in a project. So these LEDs need three things to work. They need power and ground and data. And power and ground, there's no direction to it. You just need to make sure it has a connection to both power and ground. For data, there's always an in and an out, and that's for chaining them together. So if you have more than one of these, you put a wire into the in, and then a wire to the out to the next one, and to the next one, and so forth. And then when you program this, it's 0, 1, or 2. You can refer to each individual LED with what color you want, and they all do any color that you want. So let's do a soldering demo. Get my soldering iron on. So this is working, yep. So this is like the LED that I was showing you on the screen, only in real life. And you can see that everything is nicely labeled, and it's got nice big soldering pads for demoing and not burning myself. So this is a soldering iron. It's plugged into my USB thing, but you can get other ones. And what you do is, the reason why I do this as a demo is because when I first got started, I'm like, wait, there's stuff that can hurt me? Like, I don't want to do this, but it's really not, you don't want to like grab that end, which you probably will, because I have several times accidentally. But it's not that complicated. Like you just, the little metal pads here, you do that. Let's see here. You get little pools of solder on here. Okay, and that. Good enough. So you can even do it when your hands are shaking because you're giving a presentation. So then you get wire, and you strip off kind of the insulation part, so it's just metal. And then sort of melt it back on like that, so it stays Stay there. Like that. And one more. There you go. Like that. So there you go. And that looks like it shouldn't short out. Yeah. That's not the most beautiful job, but you get enough practice in it and you can do it. I believe in you. So with those 3 wires and that LED, you take the photon, which I put somewhere right here. And so there's there's different pins on this. There's D pins and there's A pins, which is digital or analog. Now, most of the time you're using digital pins, just because for these things, they use a library to transmit like what you want it to do, and it goes through the library and then transmits the ones and zeros to communicate with everything for you. So it's not, you mostly just use the digital pins. But on here, you just, so I'll put the data pin in D3. I could show you this if you wanted to see it, but it's just kind of matching stuff up with labels, so. Power goes into V in, which you might say, that's V in. That sounds like voltage in. Why are you putting it to power an LED out? And that's just the thing with the photon. When you plug power a photon with over USB, the VIN is a VOUT, VIN out, power out. So we'll plug this in, and I'll make sure that my phone is as a Wi-Fi. So yeah, the photons that I'll be using today, they're using my phone as a Wi-Fi hotspot. And then we'll go to particle. So like I said, the particle, you can program it on LED test. You can program it with anything, or with the VS Code has an extension for it, but I really like their online one, IDE. So this program is pretty simple. You set up this strip, the strip as a global variable to the program. And in setup, you run strip.begin. That tells it like, hey, we have a power strip, or we have an LED strip coming. And then I split this up just because you end up usually splitting out things out of your loop just to keep stuff organized if you're doing multiple things. And all of this is so you take the 0th LED, so we only have one LED, and we set it to 0 red, 0 green, and 255 blue. You go into your devices, and you make sure the right one, so that's this one. You can verify it if you want, and that shows up down here. Are we? Yeah, we're good. And then you flash it. And so the photon here, there's a little blue LED here, and it will start, it'll turn to pink and go through some flashing when it is running the program. And then if everything goes great with my soldering job, nope. What did I do? Well, no, that's right. Can I change this? 1, 2, 3. Well, I'm going to show you more LEDs anyway. That's disappointing. What's wrong with you? It's supposed to turn blue. We're going to get onto other LED stuff later, so you're not just sitting here watching me try to figure this out. But stupid thing. But if this LED did light up, even that would not be that impressive, because you could do that with a regular Arduino. And why do we have all this wireless stuff, and why am I paying extra money for this internet connectivity that we're not using? And the particle cloud is what it is. So there are 2 functions I'm going to be demoing here for the particle cloud right away. It's particle.function, which allows you to send a command to hardware remotely, and then particle.variable, which exposes a variable from your hardware program to the outside world. So with particle.variable, in your setup function, you say particle.variable, and you give it a name, and then you tell it what variable to point to. And then later, in your website or your server or whatever that you're talking to, you do a get to api.particle.io /, your device ID, which is found under the list of devices. Each device has a device ID. And then your account has an access token, so that way you can keep it secure. And you pass that along, all that along, and it will return to you that variable. So in this case, it was the temperature variable, and it was 72 at whenever this ran. Particle.function does the other way around, where so you say particle.function and you give it a name, and then you say set LED, and you set LED is a call to a function that will then run some sort of hardware code for you. So to run that, you do a post to the same kind of particle API, but and then you name it the same thing, and you pass in your string. You can only pass in a string, so like this function, there's a lot of stuff here, but all it is parsing out a string to get the different sections out, because we need the index and the RGB value. And then it will run that code, and it will return, there's a return value there, so you need to return something. If you're getting really fancy, you can be like, if it did, you can say, have different number codes for what happened, but I just have it return a 1. So we'll do that right now, and hopefully this will work this time, because that would be great. So I have a thermometer here, and then I have, instead of one LED, I'm using some pre-wired ones. And I'm going to plug in, so again, it's just power ground for both of these. So ground and power. And I chose pin D3 for the LEDs again. I really like the D3 library, that's why I used that one. That's why, there's no other reason. And then do that for the LEDs and do, oh, no, this goes thermometer D0, LEDs D3. And then we'll plug this in, and it will connect. So then for this program, most of it is just the example code for the thermometer. So there's a lot of stuff here, but here's your set LED command, and again, it's like get the index of the first comma, get the index of the second comma, and then split it out. Like it's, if you do JavaScript and like form stuff, pretty standard issue. The thermometer stuff is a little bit more complicated, but again, I didn't write this, like this was all in the example. And all this does is in your loop, you specify a sample interval, and it will get how many milliseconds were there between the last time it sent a sample. And then if it's outside of that range, it will take another sample. So it's just looping through and making sure that you get the sample interval, looks like every 2.5 seconds. So everything is set up still, like it has the name of the device down here, and we'll flash this again. So there's two ways when you're in development here, and you're just kind of testing. One of the nice things that Particle has is their console. So this will go through, and when you publish an event, it shows the events for all of your functions and variables. It'll show it on the side. I think this is still paired to my phone is the problem, but yeah. So, and then to be more international, I had a temperature and it was just returning Fahrenheit because this was a presentation I gave in America. But now there's two variables. There's temp F and temp C, and so this is returning 32, which is 0, which means that's not working. Did I screw this up? Let's see here. I can't have 0 to 2 with demos that don't work. That's not fair. temp pin is D0. Yeah, I did this wrong. Easy peasy. All right. So yeah, there we go. So 71 degrees or 21 degrees Celsius. It's actually getting a temperature from the sensor now. And to have that work, to see what that would be like if you're actually like building something. Insomnia does not have a get bigger thing, so sorry about that. So yeah, this is your particle.io devices. This is a device ID. And then temp C. You send it. And it comes back with the result of 22 degrees and anything else that you need to do. So if you, well, I'll show you later. It's fine. But on the other side is the function part. So that function that did all the string parsing, we're going to do 0, 0, 0, 255. And you run it. And ta-da. So then I can do like LED 1, 255. Call that. And it's purple. And if I do 255 on this one, the next one will be white. Oh, I didn't change the thing. Well, yeah, whatever. But, and then, let's see, I think. And then get right to the app demo. So I bet no one has seen any jQuery today. We're going to change that. Because I wanted to show like a very, very simple site. And I didn't want to like, have all the everything there. So the way that this stuff would work for a website is having a server kind of work as the in-between and just be like a pass-through to, you don't want to have, unless you're doing pass-throughs of your access tokens, but if this is like something that you're hosting, you don't want to have your access token exposed. And so I've always had an Express server run, and like the particle tokens are all stored in a file that's just on, that's not hosted. And you call just /get temperature, and then you say, okay, and you put in a query parameter, whether it's F or C, and then it will pass through the device ID, the function, and the access token, and then you can do what you want with that. So then later in your beautiful jQuery, you do a get with the temperature, and this is all just hitting your own server. And then you can set it to be what the response is. Yeah. And then with functions, you do the same thing in the server part. So you will pass in so we have to pass into particle a string, but our server can take whatever we want. So we can define these to be separate variables. And then it concatenates them together for you just as a comma separated string, and then it sends that to particle to do whatever with. So then you have a website that you can host where it's pulling the variables. You could have it refresh. Mine doesn't do that. Keep it simple. And then for this stuff, so we can say, let's take this and make it 255. Light up. So yeah, if you can figure out the hardware part and you know how to do the web part, you're golden. You just have to kind of get that together. So there's different ways to kind of have this work, and I kind of explained it a little bit, but I'll go into more detail now. The continuously running method is what I've used for the tweet skirt and the text sash, where you have this process and it's always running and it's hitting Twitter, it's hitting Twilio, looking for new messages. And you have a database or a table of queued messages and a table of displayed messages. It looks, hey, do you have anything new? Nope, whatever. Or you just check to see if anything is, the last text messages are there, you check the IDs. If there's nothing, if it's new, you put it into queued messages. Your particle is hitting this process again on the other side and being like, hey, do you have anything new? Or the node process is being like, hey, is there anything in this queue database? If there is, then send it to the particle. You can have the hardware then do whatever you want to it, display it in text, for example. And then when you have it be successful, that message ID is sent back up to displayed messages so it knows not to repeat to display that again. And that requires maintaining that process. So you can I use forever.js to get that to keep running, but sometimes it shuts down for some reason after like a few months of not doing anything. So you do have to maintain it, and it's kind of a pain, but it's probably the best thing for like a stream, like hitting a stream and trying to capture messages from something like that. The alternative is with webhooks, where in the particle platform, you say, here's an API, here is the request type it is, and any authentication stuff. And then you can subscribe to the response from that. And you can use this with your webhook servers or like a Lambda function, and then you don't have to worry about maintaining it. It just sort of sits, unless it's a webhook server, then you have to maintain that. But for Lambda, it was really nice because you just kind of have this like Lambda function sitting out there, and then you just hit it whenever. So in the console that I was showing you before, where we are looking at all of our variables and everything, they have this webhook integration section. And you can, there's a bunch of different options here, but for just sort of a generic webhook, you define a name and then where the API is, the request type, and then different response formats. You can get into, what it's returning and any kind of authentication and a whole bunch of other stuff here. So then in your loop function, you would say you have that same sort of, this is doing it every second. Hit that endpoint, and you just, when you set it up, you give it an identifier, and then you just call it by that identifier later in your particle program. And then it brings in the data, or you can send, so I have just the string data here, but the idea would be you would send like a temperature or a GPS coordinates or something, and that sends, in this case, the word data to the web server, but then you can send whatever you want up to it. And then going back to your setup function, you say, okay, here is a webhook, look for a response from it. When you get to that, when you get a response from this webhook, send all of that data to a function, and you pass in a function name, so like change handler, for example. And in that data thing, the data parameter on the end there, you can get in anything that it got back. So like an example, I gave a talk for the Framsia user group yesterday, and I had a GPS device in with the particle, and I would hit a webhook with GPS coordinates, and the Lambda function would run some numbers and give a popularity score, and then send that back up to it, and then the lights would light up depending on what that popularity score is. And in this case, I don't have to maintain anything. That Lambda just sits there and doesn't do anything until I hit it again. It's really nice. So for front-end people, most of us like to use JavaScript. Well, not like to, but have to use JavaScript. And there's some other options out there. And the good part for particle stuff is it's fully extendable. And like if you have problems with it, you can talk to an electrical engineer, and they'll know C and usually Arduino stuff. It's a little bit more generic to what everybody is doing with Arduinos, and it's more understood by the general hardware community. And it also is more scalable. Particle has they do fleet management. They are in the business of trying to help startups implement IoT ideas. And so if you decide to go further with this or sell some, you can integrate in with Particle, and we'll be happy to help you with that. The bad part about this specifically is you are locked into the particle platform. I mean, the cloud is there, like that's what your in-between is. The nice part is if you ever need to migrate it out, your code is standard C, and you can kind of migrate it to another kind of microcontroller, but you would have to build that middle part. And it does require C programming, which is it's not easy. It's not super difficult, and you can Google your way out of it, like I always figure out how to do, but you do have to learn, kind of work with another language, which is sometimes hard for people. But there are other options out there. There's something called nodebots, or using the Fermata protocol, which you write JavaScript, it decompiles down into code that the Arduino can run then. And so then you get to write JavaScript, the language that you're sort of used to, and you can just program the whole thing in JavaScript. And this works with any Arduino board that you would want it to. Another option is the Tesla 2, which is a specific board. This is a board and something that goes along with the board. And it's sort of all packaged together on one thing. It does have wireless and everything too. And it just packages up commands and then routes them to where it needs to go on like the Arduino for Arduino code. So with this stuff, there's no setup, no loop. That's all just kind of with C and Arduino stuff. And your blink function, instead of being the setup and loop or whatever, you require the Johnny5 library or the Cylon library or whatever library you're using for this. You instantiate the board with that library, and there's this onReady, and the library for LED has a blink command, so you don't have to do the loop. It just will do the loop for you. And in something a little bit more fancy of a program, you do the dreaded set interval, but it's kind of how you have to do it, where it will loop through that function over and over again. And this is how you would kind of do the same loop function, but without the loop function. So the good parts of this is it's all JavaScript. You can just stick to one language, and if you're trying to teach JavaScript and you want to kind of just stick with that, you can do that, and you can totally do that with hardware. The bad part is it is all JavaScript, so you know sometimes you get sick of JavaScript, but yeah, it's true. And you're also like dependent on whatever library you're using to make this stuff work. And if you run into problems with it and you try to telling like a C electrical engineer, you're like, hey, my LEDs won't work. And they're like, okay, cool, let me look at the code and like, here's some JavaScript. The electrical engineer is going to be like, what are you doing? This is, I can't help you. So this is a little bit more dependent. If something needs to be super customized, it's going to probably be a little harder to do that, and maybe harder to find help. So let's get to some tips for beginners. Always, always, always start simple. So I help a lot with hackathons, and kind of the biggest problem that I see with groups that want to kind of do their first hardware project in a hackathon is they have these beautiful, grandiose ideas, and I love them for it, but you want to stick with a sensor and a microcontroller. What can you kind of do with that? Is it putting it in a box? So the last hackathon I was at, we put a scale, and you can build like outdoor cat shelters for when it's winter out of a big tote, like a plastic tote, and cut a hole in it. And it was a scale on the bottom of it, so when a cat came in to like bunker down in your little cat house, it would say, okay, there's a cat in here now. So start simple and build up. And then you can add, we were thinking LEDs to show when there's a cat in there. You can put like heat sensors in it. You can always build up, but just starting with a simple idea will keep you from being so frustrated of just trying to get 20 ideas in at once that you're just sort of like, this is never going to work. But so start simple and build out. And the same thing with clothing. So the tweed skirt is a circle skirt, which is just you take a big thing of fabric, you make a donut of it, you just cut a hole in the middle and cut around that hole. You have a donut of fabric. It's just super simple. And that was it. So if something wasn't working or whatever, or I cut a hole in it, or I burned something or whatever, it wasn't that hard to come up with the base of what your project was. And don't do something like this. So this is a Jacob's ladder that someone built with knives. And this was probably my favorite like hack the day project or something that I saw, because it's like, this involves sharp objects, high voltage, and mains voltage, with the unique possibility that you can both cut and electrocute yourself at the same time. Like, do not start with something like this. Start with something that is nice, and yeah, not like this. And you don't have to start with wireless. When I come up with a new project, even if I know that it's going to go to wireless sometimes, I go with an Arduino Uno first, because you don't have, like, when you do flash code to a particle, it goes up into the interwebs and all the tubes and then comes back down onto the device. And that's fine, but if you're just trying to, like, you want a tighter loop if you're going to be playing with programming. So having an Arduino Uno, it plugs in with USB. You flash code with USB. It's a lot faster. And most of the time, when you're done with, when you get kind of the base idea on your Arduino Uno, you copy paste it over to the particle platform. You probably have to tweak it a little bit, and you have to expose the right things or whatever to make it work with what internet, but it will totally work just out of the gate. Find friends. So out there in the hall, this was when I was in Minnesota, I was trying to find groups in Norway, and they actually have a booth out there. So is it Bitraf? I don't know how you pronounce that, but yeah, and they do meetups, and they have a hackerspace, and I'm sure if anybody here has any questions about hardware stuff, they'd be happy to help you with that. There's a podcast called Embedded FM where they get a variety of different speakers from, like, they had me on, and I'm just like some noob that does this stuff. They have like a NASA engineer on the next week. It was super cool. They have a variety of different people. Even if you just subscribe to the podcast and sort of decide what episodes you listen to, you can get like a really big, diverse group of people doing different things in this. And then so I showed you the temperature sensor and some LEDs today. For other things that you might be wanting to do, what I always first do, if I don't even know what I'm getting started with, is I'll just Google Arduino and display a thing, or measure like weight or something. And you'll get different like tutorials on how to do it. And in those tutorials, we'll name like the chip number or some sort of like the part number that you can kind of use to go forward. And so even if you don't have any idea of what you're doing, there's usually someone there that has done something around of what you're doing, whatever you're trying to measure, and you can always build off of that. With particle stuff, if you're going to go to that, you need to make sure that the library is available. So like when you get in here, there's this library thing here. And so these are ones that are done by the company. They have other ones that are super popular. I don't know, no, probably not. Oh, maybe. But yeah, you can just, whatever sort of part that you have, you kind of want to make sure that that part's going to has a library for it for particle, because you absolutely do not want to import, like build your own particle library on one of your first projects. It'll drive you crazy. And then, oh yeah, before I flipped over there, I should say, Particle also has like a really active community, and whenever I've had a problem before, one of the first things, and like if I Google it and it doesn't seem to help, you can go onto their forum and see what other problems other people have had and ran into, and get some pointers there, whether it's what the part number is, or if you find that your part number that you want, that you like did in your first Google isn't helping you. I mean, you could even start here, but most of the time, most of the parts that people use they're already been ported over. And then if you have some, are getting a specific error or something, you can always find that there. It's really, really active, and they're very helpful. So there's other libraries too for LED stuff. The LED library that I use just is very basic, and it just does sort of, like, it just changes an LED from one color to the other. But there's this other library called Fast LED that is a little bit harder to program, but it will do fancy stuff like this color blending for you. So this isn't like an LED going from one color to the other. It's like transitioning that color over. I don't necessarily recommend it for beginners because it is a little bit harder, but there is other stuff out there for if you want to do fancier effects. And like for when I wanted to do like a fire effect once, I just did Fast LED fire, and there was totally something there for already. And so buying components, because you actually have to get this stuff. It's better to Google, or if you're going on, I buy most of my stuff off eBay, because you can find, there's a lot of people that will sell this stuff on eBay. And so there's, like I said, there's the friendly name and then the chip name. The friendly name, a lot of sellers will use it, but you can usually find more listings under the actual part number, because these people are just putting out part numbers on eBay. And most of it is from China, and it's super cheap, but it will take about, well, if you live in America, it takes about like a month and a half to get to you. If you get just like the cheapest shipping available, it will take a while. I don't know if that's different here. But one thing you can do is for like LEDs, there's enough people out there that want these LEDs now that they will bulk ship them to US warehouses, and then you can get them from there. So you can, on eBay, you can say like where you want it to be shipped from, and you just choose your country, or they probably have one for Europe here, and you can make sure it's not coming all the way from China. So yeah, wearable tips. Again, for wearables specifically, start simple, build up. I talked about the skirt thing already. Think about batteries. Like, first thing, batteries are boring and they're heavy and they're a big buzzkill when it comes to wearable stuff, but you need to think about them because it will be the worst thing to have as an afterthought. One of the first skirts I made, I was like, oh, I'll just figure out batteries later, and I put it like along the hem of the skirt, and it was clunking around as I walked, and I sat on it, and it was uncomfortable, and it just wasn't a good. So don't be like me. You have to think about where they have to go. I generally like for like the small of your back is a good place because it's pretty stable, and I usually use for batteries now these like the phone charger batteries. This is like this has a pretty good capacity. They already output the voltage that you need, and they're nice. And so everything else you need to think about how it will be anchored to the fabric, and then how they will interact with your body as you move around, whether that's moving or sitting or whatever. And one other thing too, so like when I showed off the mask, it was kind of a demo on how neat sort of white fluffy things do really fun things with light. So what I'm showing here in these pictures are you have just the LEDs, and if you put black cloth over it, the lights are very focused and pointed, and so it's harder to see letters and it's harder to see pictures because everything is just these little points of light that are far away from each other. And the solution to this is if you throw something fluffy and white like terry cloth, like a washcloth or a towel, over it, it will diffuse the light out like this, like just sort of have the colors blend together. And then you can put whatever you want on top of that, and it will still have, because you don't want to be wearing like what looks like towels, but you can put black fabric on top of it, and it will still have both. So like the sash that I had, there is a layer of terry cloth in there that helps the light sort of diffuse into each other. So a couple other talks here today, not just today, but while we're here at NDC. So I talked a lot about Particle. One of the developer relations people from Particle is here, and he's giving a talk on Thursday, tomorrow, at 4:30 or 4:20, the same time as me, about so like most of the time you send, like when you're doing a lot of data and machine learning on data, you have to send it somewhere and then have it send the result back. But you don't have, he's got some fun ideas for how you send the data to where the computer, probably not a Particle because I don't think it's got a lot of memory, but like a Raspberry Pi or something, and you can do it on that. And then on Friday, there's a couple people giving a talk on, if you're a hobbyist like me, it sounds like these guys worked on a controller, and they were able to actually design it and produce it and make more of them. And that is a very, very difficult thing that I've never done before, but they're going to explain how, and that sounds really fun. So anyway, thank you so much. The code for all of this is on my GitHub right there. So that's both the server and the hardware code examples, and I'll probably throw the slides up there too, so we have that. But yeah, thank you so much. And I have time for questions too, if anybody has any. I can't see anybody really well, but okay, I think we're good.